SPC Tool Histogram, Chapter 3. The histogram is another of the SPC tool. This methodology helps us to monitor a process and to identify special causes of variations and signal the need to take corrective actions to eliminate them. The histogram is the 6th of the 7 tools of the SPC series. It is another visual tool and graphically shows the process capability and, if desired, the relationship to the specification and the nominal. Customer requirements are translated into a specification that goes to the production process. In the production process, those specifications must be met to make sure that the organization is producing what the customer wants. Some of the advantages of using histogram is that help us to see the large amount of data that are difficult to interpret in tabular form. Also shows centering, variation, and shape. Illustrate the underlying distribution of the data. Provides useful information for predicting future performance and helps to answer the question, is the process capable of meeting requirements? Histograms are well known. During the semester, we're going to understand different distribution types, and the main one used is the normal distribution. Histograms, we want them to be normal distributed because it's easier when they are to understand where the mean, the median, and the mode are located. With this, it is also possible to see if the process is capable of meeting those requirements, because we're going to also graphic those specification limits, the lower and the upper, and see if the process is capable of meeting those requirements. How do we build a histogram? Step number 1 is, once you have the data, you have to calculate the range of the data. And the way that we calculate the range is taking the largest observation and the small observation and subtract them. Step number 2, you choose the number of classes or beans. And it's usually a number between 5 to 20. And the rule of thumb is that n represents the number of data points. The number of beans should be approximated the square root of n. We have a table. If you have less than 25 data, you should use a number between 5 or 6. If you have between 25 and 50, you should use a number between 7 and 14. And if you have more than 50, you should use class between 15 and 20. Once you determine the class, you have to determine the width of that class or the different classes. And the way that you do it is you divide the range by the number of classes. Then you determine the class boundaries. So you find the number of observation in each class, and that will determine the frequency for that specific class. And then you draw the diagram. Histograms are used to describe the variation in a process. The histograms will help you to understand how the data behave. It helps to solve problems, determines the process capability, suggests the shape of the population, and indicates discrepancies in the data such as gaps. To build it, you can use Excel, you can use Minitab, or you can do it by hand. So let's work an example. These are the inside diameter of metal sleeves. And we have a sample size of 25, and these are the different data. So if you do it by hand, the first thing that you have to do is to find the range. And to find the range, you have to find the largest observation and the smallest observation and subtract them. So the largest observation is 4.75 and the smallest observation is 0.2. The subtraction of them give you a value 4.73, and this is the range. The number of classes, what you can do is, because you have 25 and 25 tells you that it could be between 5 and 25, you can have between 7 and 15. I choose the lowest one. which is 7. Then once you determine the number of classes, then you have to determine the width, okay? And for this, you have to divide the range by the number of classes. And it gives you around 0.676, and you can round it up to 0.7. So that's the width of the class. Then you have to determine the class boundaries and count the number of observations. So for example, you determine that the lowest boundary will be 0.015. Then you add that 0.7. That will give you that the limit for that class is 0.715. Then you start the next class with that plus 0.7, and that gives you 1.415. Then you start the next class with that number, and you add 0.7, and that gives you 2.115. Then you determine the frequency. You go back to the data, and you said, okay, how many data set that I have here falls in the first class, or in the second class, in the third class, and then you plot the data. So let's use Minitab to build it. What you do is you open the Minitab, a worksheet, and then you enter the data in one column. So I have the diameter, and I have all the 25 data. So I have 25. Okay. Once you do that, then you go to graph and you select histogram. And it tells you which one to use. I'm going to select the simple one and click OK. Then it's going to ask you for what variable. Then you double click the diameter, and the diameter variable is in that diameter option. And then you click OK. And they give you the histogram. You also can do, when I select graph and histogram again, I'm going to select with fit, so we know it's easier to understand the curve. And I'm going to go to data points, and under frequency, select the diameter as a frequency. And I give you another graphic with the curve. This is the normal distribution, so you can see if your data is close to a normal distribution type. Also give you the mean, which is the average point for that data set. Okay, if you can use Excel as well. So what you do in Excel, you also copy the data in one column. Then you go to data analysis. Under data, you select histogram. You click OK. Then you select the data from the first to the second one. I check in the label because I'm adding the diameter as a part of the data. And then you select the chart output and click OK. The difference between this histogram and the one given by Minitab is that the histogram here, it tries to locate it based on the main data points. So if you see that they look a little bit different, it's because of that. But it gives you the same understanding. So you can see that based on this one and the histogram made by Minitab, that you can set that the data is shift to the right. We're gonna see and understand this more in this semester. So it's no standard normal distribution because it's no well shape, but you can say that it's a little bit switched to the right. So this is all for histogram, and histogram is another of the SPC tool.